This is Clayton. Clayton is curious to know if he could be as powerful as a tornado by simply spinning fast enough. But I'm getting ahead of myself. Let's first introduce tornadoes. According to the National Weather Service, a tornado is a violently rotating column of air touching the ground, usually attached to the base of a thunderstorm. They are considered amongst the most violent storms. The recipe for a tornado consists of warm, moist air at the surface, cool, dry air aloft, lift, and shear. Clearly, humans lack many, if not all, of these properties. So now what? By spinning fast enough, Clayton might be able to overcome some obstacles that could replace these necessary components. Well, how about a hurricane? Could Clayton be as powerful as a hurricane? According to NOAA, a hurricane is a tropical cyclone in which the maximum sustained surface wind is greater than or exactly 74 miles per hour. Now, let's talk about the data behind Clayton's desire to mimic severe weather.
According to Kerry Emanuel, a hurricane can be modeled by a Carnot cycle. In the first leg of the cycle, air is lifted isochorically into the hurricane and cooled. In the second leg, the air is warmed isobarically. And in the third leg, the air travels along an isotherm to its original position. To calculate how much work is done to the system under these thermodynamic conditions, we can use the first law of thermodynamics and find that about 12.14 grams per joule of work is done to the system from the environment. If we increase surface temperature by 2 degrees, a low estimate of climate sensitivity for a doubling of CO2, the work done to the system increases. Our surface isotherm is now 2 degrees hotter, and based on the ideal gas law, our pressure has deepened and the density is decreased in the hurricane. In this scenario, about 12.6 joules per gram of work is done to the system, an increase of 3.8%. This is a diagram of hypothetical hurricane maximum wind speed from Kerry Emanuel, and we've highlighted a realistic scenario with 2 degrees of sea surface temperature warming. From 78 meters per second to 82 meters per second, this is a 5% increase in predicted hypothetical maximum wind speeds. But by far, the way in which hurricanes would become more powerful in a changing climate would be through its flux of latent energy. Qualitatively, looking at this equation, if we were to take the difference of latent energy flux at 27 degrees Celsius versus 25 degrees, we can see that none of these constants on the left would change. Q sub A of Z wouldn't change very much as well. That's just the conditions in the hurricane. Q sub S would be the main driver of latent energy flux increase, because that's the specific humidity right at the surface of the water, which is now 2 degrees hotter. As you can see, more powerful hurricanes would arise from climate change, but nothing compares to the most powerful severe weather of all, Clayton spinning in a chair. According to special relativity, if you spin very close to the speed of light, your angular momentum would approach the Earth's. This would rob the Earth of all its angular momentum and completely stop the Earth. This would most certainly cause enough wind shear and air mass mixing to start some tornadoes. So yeah, you could spin enough.